Hello, this is Mrs. Brown, and today we're going to be looking at combining like terms, which is also known as simplifying expressions. It's the same thing, it just has two different names, okay? We're going to start today with some vocabulary. So if I look at this expression, 4a plus 7, remember that means 4 times a plus 7. 4 is the coefficient because it is what we're multiplying by the variable, which is a. Remember, variables would be things like letters. Those are things that change, depend on the situation. And then the constant is 7 because it's not being multiplied by a variable. It's all by itself. So it always is 7 no matter what. So the number being multiplied by the variable is the coefficient, and the number that's all by itself is called a constant. So we're going to look at a couple of examples. So 9 plus 3x. So if we look at the coefficient, remember the coefficient is the one that's being multiplied by the variable. In this case, my variable is x. And so 3 times x, because 3x means 3 times x, means that 3 is the coefficient. And 9, because it's all by itself, is going to be my constant. Okay. When I look at the second one, 4 times a times b, so 4ab means 4 times a times b. My coefficient 4 is being multiplied by the variables. And in this case, I have two variables, and I do not have a constant, so that's not applicable. Okay. If I look at this question, I've got 1/7 times m. Ooh, fraction. Doesn't change anything. 1/7 times m plus 2n. So I actually have two coefficients, 1/7 because it's being multiplied by m, and 2 because it's being multiplied by n. And then I have two variables, m and n. And again, I didn't have a constant because I didn't have a number by itself like I did up here or up here. Okay? So now that we've talked about some of the vocabulary, let's talk about one more important thing, and that's terms. Terms, if we're going to combine like terms, we have to know what a term is. Terms are things that are separated by an addition or subtraction sign. So if I look at this first example, this is a term, this is a term, and this is a term. So my terms, I have 3 for this first expression, and it can be consisting of a number and variables, just a variable, or just a number. So it could be just a constant depending on the situation. So if I were to list the terms, I would say 8x squared is one term, 4m is another term, and 3 is the last term. And so it makes it for 3 terms. Okay, again, they're separated by addition signs. Now, when you look at a question like this, and I know that we've talked about this previously, subtracting a positive number is the same as adding a negative number. So I would rewrite these as all addition. In other words, instead of saying minus positive 3n, I would say adding negative 3n. Because again, it's going to give you the same value. If you think about it, if I had 5 plus negative 3, that's the same as 5 minus 3. In either case, I'm going to get 2. So subtracting a positive number or adding a negative number gives me the same thing. And this way, you're not as likely to mess up on identifying the terms because this has to be counted as negative 3n. Okay? So the terms for this one then are going to be negative 7n squared, which is 1, negative 3n, which is 2, and 5, which is 3. So again, this one has 3 terms. Okay. Looking at this next example, again, I would go ahead and rewrite this so that my subtraction signs are plus a negative. One of the main reasons, besides making sure that we get the negative sign where we need it to, is that you don't have a commutative property of subtraction, but you do have a commutative property of addition, which means you can change the order that you add in. So it allows us to combine things even when they're not right next to each other. So that minus sign becomes plus a negative. And from there, I can again identify my terms. I'm going to have 1, 2, notice that negative is with there, 3, 4. So all these are like terms, okay? So now let's talk about how to combine them, okay? In order to combine like terms, constants can always go together, so it doesn't matter if they're positive or negative, fractions, decimals. The constants, the numbers that are by themselves, can always go together. And terms with the same exact variables can be combined. It doesn't matter what their coefficients are, as long as they have the same variables. So if I take a look at this example, again, first thing I'm going to do is rewrite it so that the minus is now going to be a plus sign. And that way I can add in any order that I want. It doesn't matter. So that minus 3a is going to become plus a negative 3a. Minus a negative cancels. Our shortcut for that is addition. So that double negative next to each other. And so this is my new problem. Now, I'm going to put stuff together that goes together. So I'm going to start with the constants. So I'm going to look for all the constants in the problem. So I've got a 5 here, and I've got a 4. This one and this one are coefficients because they're being multiplied by a variable, so I can't combine them. 5 plus 4 is 9. Okay. Then I want to look at the ones that have just an a. So I've got 8a, I've got negative 3a, and I've got just plain old a. Sorry, I did the triangle the wrong way, that one. All right, so when you take a look at this, I always think of it like something when I'm doing this. It actually works a lot like units when you're adding and subtracting units. And so some people get confused about what happens to the variable and stuff. This is why I think about it this way. I'm looking at a. First A word that pops into my head is apple. So I have 8 apples. I take away 3 apples. Now I have 5 apples. And then I add 1 more apple and I have 6 apples. So this would be 6a plus 9. Again, think of the variable as something, and it helps a lot. So I have 8 apples minus 3 apples, which is 5 apples, plus 1 apple. And I know it's just 1 apple because it's just an a, so it's going to have a coefficient of 1. And so that would be 6a plus 9. So let's look at another example. Okay. Again, I have a subtraction, so I'm going to rewrite that as plus a negative. So I make sure that I have the right sign because subtracting a positive number is the same as adding a negative number. And now I'm going to look for my constant. So when I look, that's a coefficient, that's a coefficient, that's a coefficient because they're all being multiplied by a variable. And so just plain old 7. So that's going to be the last bit. Now here's an important thing. X squared is not the same as x. Because x squared, literally think of a square. This is just like a kind of like a line. So they're two different things. So you can't combine squared and not squared. So when I look at that, this one's squared, this one's squared, this one's not. So I just have my 3x. And then I'm going to finally look at the squares. So I've got 4x squared and negative 2x squared. So in other words, like 4 xylophones minus 2 xylophones is going to be 2 xylophones. And don't forget the square. Okay, so combining this would be 2x squared plus 3x plus 7. Okay, just a couple more quick examples so that you get an idea of what you are doing. Okay. All right. So taking a look, first thing I'm going to do is rewrite the problem because there's a subtraction sign. So I'm going to make that a plus a negative. You will save yourself many, many issues. They'll just never come up if you get in the habit of doing that first. Again, it allows you to add in any order. Okay. Now, we're fruit. Okay. Bananas, apples. They're two different things. I can't put them together. Okay. So I can only put apples with apples and bananas with bananas. So I've got 3 apples and 4 apples. So 3 plus 4 is 7 apples. Plus I have 8 bananas, and then minus 2 bananas would give me 6 bananas. And so that would be fully combined. Okay, you can't add these together because the variable's different. We don't know what A and B are, and so we can't combine them together. All right. Last problem, again, I see a subtraction sign so that I can just add them all together. I'm going to change that to plus a negative. It just makes my life so much simpler because I can use the commutative property. Okay, I see I have constants here, so I'm going to start with the constants. Okay, I've got a plus 4 and a plus 7, and so to combine 4 plus 7 is 11. And then I'm going to take a look at my variables. They're all plain x's, no x squared, so I can put them together. So if I have a negative xylophone minus 3 more xylophones, so that's going to be negative 4, and then plus 9 xylophones, that's going to give me 5 xylophones. If it's easier for you, you can start with a 9. I have 9 xylophones. I take away 3, so I'm left with 6, and I take away 1 more, which means I'm left with 5. And so the final answer is 5x plus 11. Okay? You know where to find me if you need help.